Now we look at the second problem, which concerns with the SAT. The SAT is a standardized test used for college admissions in the United States. The national mean verbal score in 2010 was approximately 508, and the standard deviation was about 47. An education researcher questioned that a large urban high school produced better verbal scores relative to the national level. And a random sample of the test scores of 30 seniors from this high school in 2010 reported mean verbal score 515. So this 515 is the sample mean. Okay, for the first problem, based on the situation provided, state the null hypothesis HO and the alternative hypothesis H1. Okay? So in this situation, this researcher questioned that this large urban high school produced better verbal scores relative to the national level. So the H1 will be the mean verbal score of this high school is greater than the national level, which is 508. So if we let mu be the mean verbal score of this high school, then we test HO, which is the null hypothesis, that is mu, the mean verbal score of this high school, is equal to the national level, that is mu equal to 508, versus the alternative hypothesis, that is the mean verbal score of this high school is greater than the national level, that is mu greater than 508. Okay, this is the first part. And the second part, we're going to calculate the z-test statistics and calculate the p-value. And to find the z-test statistics, we know it is equal to z equal to the observed sample mean, that is 515, minus the population mean, that is 508, divided by the standard deviation, and which is 47, divided by square root of 30. Basically here we applied the central limit theorem. Okay? And then if we do the calculation, we can get z is equal to 0.815757. Okay? This is the z-test statistics. We next find the p-value. Remember, the p-value is the probability of observing data as extreme or more extreme than what we have observed in the direction of the alternative hypothesis when the null hypothesis is true. So that means because here our alternative hypothesis is u greater than 508, that means we're looking at the direction in the greater direction. So that means the p-value is equal to the probability of observing as extreme or more extreme, that is z greater than or equal to 0.815757. And if you look at the table or using a calculator, you can see this is equal to 0.2073. Alright, this is the second part. For the third part, we want to conclude about this problem at the fifth significant level. Because we find the p-value is equal to 0.2073, which is greater than 0.05, that is 5%, and then we fail to reject HO. Okay, this is the statistical conclusion. But from the problem, we notice that we need to state the conclusion clearly in both statistical and contextual settings. So this first part here, we fail to reject HO, is the statistical setting. In the context of this problem, we are going to conclude that is at 5% significant level, there is no evidence showing that this high school produced a better verbal score relative to the national level. Okay, this second part here is the contextual conclusion of this problem. Now we go to the next part of this problem. Basically, we have the same setting, but we're going to construct a 95% confidence interval for the population mean verbal score in 2010. Remember that the confidence interval is given by the sample mean plus or minus the critical coefficient, that is z alpha over 2 times the sigma over square root of n. Okay? Alright, here we know that alpha is equal to 5%, or equivalently this is 0.05, and the sigma from the problem we know it is equal to 47. N is the sample size we have in this sample, which is 30. And then from the normal table we know that z sub alpha over 2, that is z sub 0.05 over 2, that is z sub 0.025 is equal to 1.96. And finally, we know that the x bar here is equal to 515. Now we plug in all the numbers into this formula. We have the 95% confidence interval is 515 plus or minus 1.96 times 47 divided by square root of 30. And if we do the calculation, this is equal to 498.18 points to 531.82 points. Okay? Because here it is an actual problem, we're going to take the unit with the numbers in the confidence interval. Alright, this is the fourth part. Finally, we look at the fifth problem. Suppose that the education researcher wishes to carry out a follow-up study in which they estimate the mean verbal acid score with a margin of error of no more than 15% at a 95% confidence interval, and we want to determine what sample size should they use. Remember, the margin of error is this part, which is so margin of error is equal to the sub alpha over 2 times sigma over square root of n. If we plug in the numbers, we have the sub 0.05 over 2 times 47, which is sigma over square root of n, and n is an unknown quantity we want to determine in this part. And we know that the sub 0.05 divided by 2 is 1.96 times 47 divided by root n. This margin of error is less than 15 points. Alright, if we rearrange this inequality, we actually have square root of n is greater than 1.96 times 15 times, sorry, it is not 15, times 47 divided by 15. And if we square both sides, we have n is greater than or equal to 1.96 times 47 divided by 15 square. And this part is about 37.7. So n must be greater than or equal to 37.7. But n is the number of people, the number of the students. It has to be a whole number, so n should take on 38. N should be at least 38. So this will be the final result of this problem.